G'day Year 7s and welcome to another one of your favourite times watching one of my fabulous video tutorials. Now I'm going to give you a bit of bad news. This one may go for a little bit longer. There's a little bit to get through, but we'll see how we go. If necessary I might break it up into two videos, but yeah, bit to get through, but I'll try and do it as quick as I can. Algebra. That's what we're doing. Alright, chapter 5 of your textbook. So algebra, I know a lot of you've probably done a little bit of algebra, but my usual experience when I'm teaching algebra is kids just throw the arms up and go and just say, it's full of letters, I don't understand why letters are part of maths, I don't get it. Okay, but as usual, I'm here to help you get it, and you are going to get it, alright, provided you, again, do the work, do the right thing, listen, pay attention, you will be fine. Okay. First thing you need to know, and there are going to be some terms, alright, and we will look at these terms very shortly. But a bit of an introduction. A pronumeral, also known as a variable, is a letter. Okay, so it could be anything. Could be A. No, actually I won't use that because it looks like a 9. Let's say a B. Okay, that is a pronumeral. Alright, it is just a letter that can represent any number. So it can represent any number. Okay, so when we are, and there is another video that I'm going to link into Edmodo that talks about the letters and why they're used, and we could use anything in algebra. You could use a picture of a banana, we could use a picture of a smiley face, we could use a picture of a car, it doesn't matter. Okay, but one of the things with algebra is that they use letters to represent numbers, and it is a variable. That's why we've got here also known as a variable. So the letter is a number that could change, it could vary, it could be anything. Okay, we could decide what it is, or the problem itself is going to decide what the number is. Okay, but it can represent, the letter is just there to represent a number. Okay, the choice of the letter used is not significant. Okay, it doesn't matter what letter we use, but to aid our memory and to aid the problems that we're working through, sometimes you might use letters that represent part of your problem. Alright, so for example, if you're looking at someone's height, for example, you might use the letter H. If you're looking at someone's weight, for example, alright, you might use the letter W to represent a person's weight. Okay, so rather than writing the whole word, you'll just write a letter to represent a particular number, and that number could change, it could be anything. Okay, and I do recommend, it's only a 3-minute video that I'm going to post on Edmodo. I really recommend you do watch that. Alright, this stuff I want you to write down, summarize it. Okay, you don't have to write all this word for word, but you need to have a definition of a pronumeral. You need to have a definition of what a term is. You need to have a definition of what a constant is. You need to have a definition of what coefficient is. You need to have a definition of expression. Okay, so what I suggest you do is pause this or wait till I go through the explanations quickly, and then you need to write all these in your books, and I will check the books to make sure all these definitions are written up. Alright, so pronumerals we've gone through, they just represent the letters. So in algebra, letters can be used to stand for numbers. These letters are called pronumerals. Okay, so the letter C is a pronumeral. A term, actually, yeah, I'll go with a term. A term consists of numbers and pronumerals combined with multiplication or division. Okay, so for example, 5 is a term. So just the number itself can be classed as a term. Okay, a letter, get rid of that. A letter could be classed as a term. Sorry, I was getting my writing implement to work. So that could be a term. Okay, or you could have a number and a letter. That is also a term. Okay, and it could be more than one letter. So you might have 3 A, B, C. Okay, that is also a term. And when we get down to expressions, expressions are made up of terms put together by adding, subtracting, multiplying, or dividing. Okay, that was what ends up looking what creates an expression, sorry. Alright, so for example, 5 is a term, X is a term, 9A is a term, ABC is a term, and 4XYZ over 3 is also a term. Okay, so a term is just a letter or a number or a combination of letters and numbers there together. Okay, A term that does not have any pronumerals is called a constant. So if we look back at this one, 5, okay, without any letters is called a constant. Alright, so whenever you see the letter on its own, it's a pronumeral. If you see a number on its own, that is a constant. If you see letters and numbers together, so for example 5C, that is a term. And part of that term is your pronumeral and your we'll get to that one. Actually ignore that little bit that I was just starting to say then, because it doesn't quite fit. Okay, coefficient. Alright, coefficient is the number in front of a pronumeral. So now I'm going to go back to this one, the 5C. Alright, so that 5C is a term. Part of that term is this, which is your pronumeral. Okay, and this is your coefficient. Sorry, it's not writing very well. Okay, now you don't get, if the number doesn't have a pronumeral, what's it called? A constant. Okay, a letter on its own is just called a pronumeral. The letter on its own is a constant. A letter and a pronumeral, a number and a pronumeral together give you a term, and this is your coefficient. A number in front of a letter, and I may have said something different then, but I've got my mind back on track. A number in front of the letter is called the coefficient. Okay, an algebraic expression consists of numbers and pronumerals combined with any mathematical operations. So you're adding, subtracting, multiplying, dividing. So if you look down here, 3x plus 2yz is an expression. Okay, and how many terms are in that expression? Who can tell me how many terms? Take a guess, say it out loud. Okay, yep, there are 2. Hopefully you said 2. Here is one term with a pronumeral of x and a coefficient of 3. And here is another term with 2 pronumerals, a y and a z, and a coefficient of 2. So there are 2 terms that make up this expression. This is also an expression. Okay, and there are a number of terms, a couple of constants in there that make up this expression. So 8 divided by 3a minus 2b in brackets plus 41. That is an expression. Okay, so make sure you understand all those. Make sure you write a definition for pronumeral, term, constant, coefficient, and expression into your books. Okay, so if you need to pause that now, pause it and get your book out and write them in. Alright, so let's look at a quick example using this terminology that you have just learnt. Okay, so part A here is list the individual terms in the expression. Alright, so what are the individual terms in this expression? Shout them out. Do them in order from left to right. Hopefully you said, this is question A, you've got 3a is one term, you've got b is a second term, and you've got 13c as a third term. So there are 3 terms, okay, in that expression. Alright, pretty easy, not hard. Okay, state the coefficient of each pronumeral in this expression of 3a plus b plus 13c. So what is the coefficient what is the coefficient of each pronumeral in this expression? Alright, so what are our pronumerals? Which one of these are our pronumerals? Here you've got a is a pronumeral and c is a pronumeral. Okay, and what's the coefficient? It is the number in front of the letter. Alright, so the coefficient of a, the coefficient of pronumeral a is 3. Okay, that is the coefficient. Alright, the coefficient of pronumeral c is, say it, 13 is the coefficient of pronumeral c. Okay, let me throw a little bit of a curly one, because what about this one? We've got pronumeral b. So what's the coefficient of pronumeral b? Take a guess, say it out. Okay, it is actually 1 is the coefficient of pronumeral b. Alright, now when you see a letter written on its own, like b, it could be any letter, even if I wrote x, y, z, okay, anytime you see letters on their own with nothing in front of them, there is actually a 1, a number 1 sitting out in front of them. Okay, so don't be lost or confused make sure you remember, if you see a letter, a pronumeral sitting on its own, there is still a number there, and it is the number 1. So do not forget that, please. Really important you remember that. Okay. Alright, part C. Give an example of an expression with exactly 2 terms, one of which is a constant term. That could be anything. We could come up with absolutely anything there. I'm going to use maybe this. So I'm going to say 3a and minus 4. Okay, that's an expression with 2 terms, because there's one term, there's another term, and one of those terms is a constant. Okay, so there's my constant. The 4 is my constant. Alright, so not hard. Really, really easy. Okay, how to write algebra. So a couple of things. I'm going to take this 3a and this 1xyz actually. Okay, so my 3a and my 1xyz. Now in algebra you don't normally write the 1. Okay, you would only write xyz in that. Okay, so actually what I might do is I'm going to what do I want to do? I want to get rid of that. I want to get rid of my 1. So to make this a little bit easier, I'm going to write 4xyz. Alright, whenever you see a pronumeral and a coefficient together, okay, there's something happening in between here. Any idea what's happening between the 3 and the a? There is a mathematical operation, and when we talk about mathematical operations, we mean it's plussing, minusing, multiplying, or dividing. Okay, one of those 4 operations. What do you think is happening? Okay, do you see a plus sign? No. Okay, so there's no plussing. Do you see a minus sign? No. So it's not minusing. Okay, does it look like there could be a division happening here? Okay, and think about fractions and what fractions look like, and you know, when you see a fraction that is actually still dividing, so 1/2 is 1 divided by 2. Okay, so it's none of those. So between the 3 and the a is a multiplication. So anytime you see a coefficient and a pronumeral sitting right next to each other, there is a multiplication happening. Anytime you see letters sitting next to each other, so I might actually get rid of that 4 at this point. If you just see x, y, z, for example, alright, between each of these is a multiplication. It's multiplying. So if I expanded these guys out, this 3a, it would actually look like 3 times a. Okay? We just don't write, again, one of the conventions in algebra, you don't write the times. Okay? You just don't need to write it. So you write it as simply 3a. Okay? Same with the xyz. There is a times between the x, there is a times between the y and the z. Alright? So a times between the x and the y and a y and the z. There is a multiplication happening between there. And even if I had a really big, I'll put a number in front of this one, 4a, b, c, d and e, what would that look like? Say it out loud. You would say 4 times a times b times c times d times e. Okay, so that's why in algebra we don't write them, because it ends up looking really ugly and really big. So it's just not written. Okay, so just again, it's one of those things you've got to remember, that if you end up with writing something like this, the correct way of writing it is that. Okay, instead of 3 times a, it's 3a. And if you see more than 2 sitting together, each item, whether it's a coefficient or a pronumeral, will have a multiplication sitting in between them. Okay, so really, really important that you understand that. Alright, how else do we write them? Okay, the other thing you need to remember about writing algebra is, as I've written it here, numbers go first, the coefficient is first, the letters come after it, and they are all in alphabetical order. Okay, so they have to be in alphabetical order. Well, don't have to be. So I could write B, D, E, C, A. Now that technically that's not incorrect. Okay, but to be completely correct, we write the number first, and then we write the letters after it, all in alphabetical order. Okay, and it's really important you understand that and do that as well. Okay, now what we might do, hopefully this works, is I'm going to show you a couple of these little widgets. So notification for multiplication. Alright, Now I've sort of explained this a little bit. Alright, so if I've got down here P times 3 times Q, alright, the way we write it, we take the number, put it out the front, and then we put the P and the Q after. We get rid of the multiplication, and there is no multiplication used between the numbers and the pronumerals, and you just put them together, so it ends up with 3PQ. Alright, next one, if we've got a 5 times P times 2, alright, so we've got two coefficients sitting here. So what do you think is going to happen there, you reckon? Well, let's have a look. So we're going to take the 2, put it up with a 5. Alright, numbers are written before the pronumerals. So we're going to multiply the 5 and the 2 together to get 10. We get rid of the times, and we end up with P. So this 5 times 2 times P ends up being 5 times 2 times P. So the 2 comes up to the front here. Okay, we times the numbers together, and then you put the letter after it. Alright, next one along here is N times 1 times M. Okay, again we put the number at the front, alright, before the letters. We put the letters in alphabetical order, and then we get rid of the multiplying, alright, and hopefully the 1 disappears because the coefficient of 1s does not need to be shown. Again, it's one of those mathematical conventions. You're not wrong if you show it there. Sometimes I encourage kids to write it there so they remember there is a 1 sitting out in front, because sometimes that is important, but you normally don't need to write it. Alright, this last one at the bottom here, what do you reckon is going to happen here? The 4 comes out the front. Okay, we get the B to come next to the 4, the brackets go at the end, and we get rid of the multiplication signs. Okay, so numbers are written before pronumerals. Pronumerals go before grouping symbols, so there's brackets that are grouping the y minus 7 together. Okay, that goes at the end, and then we get rid of the multiplication signs. Okay, so hopefully that makes sense to you. Now I think we want to have another look at this notation for division. So that was multiplication. Alright, so if you want to have a look at that, you can get into this, your Hot Maths, Essential Maths AC7, look at the 5.1a Introduction to Algebra, and go through the 2 widgets. Okay, you can have a look at it again themselves. So m divided by n, okay, but what we actually do is write it like a fraction. Okay, that easy. When we look at this one, okay, it's a plus b divided by n. Now remember, the brackets are telling us that all of that is divided by n. Okay, not just the a or not just the b. Alright, so it is a plus b together is all divided by the n underneath. Okay, and that's how it needs to be written. Again, you're not incorrect there, but the correct way of showing it in algebra is like that. Last one, a plus b divided by n. This time, the b, because there's no brackets there, is telling us that just the b is being divided by n, not the a. Not like this one, because the brackets are telling us both of those are being divided by n. Here, because there's no brackets, it's a plus b divided by n, so only the b being divided by n. So in that case, the a sits out in front, and the b and the n are written like a fraction, with the n at the bottom being the division part. Okay, so hopefully that makes sense to you. Now what I might do now is, we're going to move on. I told you it's going to be a little bit lengthy, but it's important you understand it. Writing expressions. So actually what I'm going to do is, I might go back here. Bear with me for 1 sec. I'm going to have a look at this one. Update. Thank you. Alright, expressions using pronumerals. Okay, so we're going to quickly have a look at this. So sometimes you are going to be given, or in the first exercise, you're going to be given a description of what's happening. Okay, so take 8 from a number and then double your answer. I'm going to come back to that one. So we're going to look at these ones first before we go through that. Alright, so write an expression for each of the following. Remember, to write an expression we've got to use terms, so either letters, numbers, or a combination of letters and numbers, and then mathematical symbols and operations, the plus, the minus, the divide, and the times. Alright, and read these carefully. So first one here, A. 5 more than K. Just say, if you get confused by this, sometimes it's better to just pick a number and put it in for K. Alright, so just say I said K was 10. Now you would say it as 5 more than 10. How would you write that? What would it look like? I don't want an answer. How would you write the sum or the equation for that to be correct? Alright, so what I want you to do now is go and have a go and see what happened. See what you come up with. Pause and off you go. Okay, hopefully you have paused, because I know some people don't and keep playing straight through. 5 more than 10, what does that look like? Well, it's 5 more than 10, so I've got to add 5 onto 10. So 5 more than 10. Okay, so that if I, instead of using the k, I'll put a number there, that's what it would look like. So in this case, we don't have 10, we've got k. Alright, so if we've got 5 more than k, we're going to write k plus the 5. So 5 more than k. Okay? Okay. Alright, so read these ones very carefully. I want you to actually stop the video now or pause it, and I want you to have a go at the rest of these examples. Alright, and then we'll come back and quickly work through them together. Alright, so pause it now, off you go. Alright, hopefully you paused it, and I bet some of you haven't, as usual. But anyway, alright, B, 3 less than M. Okay, so we're going to say we've got M and we've got 3 less than what M is. So it should be M take 3. 3 less than what M is. Alright, and if we wanted to use, we put in a number if we wanted to. So 3 less than 10. How would you write it? 3 less than 10 is 7. So you'd write 10 take 3. Alright, I'm not saying that M is 7, it could be anything. All I'm telling you is sometimes just pick a number, any number, it doesn't matter. Put it in instead of the letter so you can get a bit of a picture, and then you can swap it back to the letter. Okay, so instead of 10 you said, well, instead of M you said 10. So put your letter back in, which is M, and you'll get your the same answer. Okay. C, the sum of A and B. So what does the sum mean? Alright, hopefully you've said it means plus. Alright, so the sum of A and B is simply A plus B. That's all it looks like. Really easy. D, double the value of X. Alright, so if we've got X, we've got to double it, so we times it by 2. Now remember what this looks like. Okay, we don't write it like that. What do? We swing the number to the front, put the letter at the back, but then we also don't write the times. So it is actually 2x. So double the value of x, 2 times x, 2x. Okay. E, the product of C and D. So what does the product mean? You've got to know your mathematical language here. Product. Help me out. What does it mean? Okay, hopefully you said times, multiplication. So the product of C and D is C times D. Again, how do we write it? We write DC. No, hopefully you pick me up on that one. It's not DC. It's not DC. Because, remember, we write them in alphabetical order. So the answer there would be CD. And that is a product. C times D, get rid of the times, end up with CD. Okay, so they're not too difficult, but you've got to think about a little bit because we're using letters instead of numbers. Alright, let's try some ones that are a little bit more difficult. So we've got more than one operation happening. So we write an expression for each of the following without using the times or division symbols. Alright, so like we just did in the hot maths, where they didn't write them, this is what we've got to do. So P is halved, then 4 is added. So what's that going to look like? So A, so we're going to halve P. How do you halve a number? So if I said 10, how are you going to halve 10? You're going to divide it by 2. So we're going to do the same thing. We're going to P divided by 2, then we add 4. So P is halved, then 4 is added. P over 2 plus 4. Okay? Next one. The sum of x and y. If you don't get this stuff, you remember you're watching on a video, so you can rewind and replay it. B, the sum of x and y is taken and then divided by 7. So we've got the sum of x. What happened there? Sorry, I just did something then. The sum of x and y. Whoops, where am I? Sorry, the sum of x and y is taken. So the sum of x and y. So sum means we're adding. So the sum of x and y is taken, then divided by 7. So all of that. We've got to add those two together and then we divide by 7. So it's x plus y. I might want to put them in brackets as well. Alright, just to clarify that I've got to add those guys together, then I divide by 7. Okay, so the sum of x and y is taken first, we add them, then we divide them by 7. So that's what it looks like. C, the sum of x and 1/7 of y. The sum of x and 1/7 of y. So we're going to have x, sum means plus, and we've got 1/7 of y. Okay, and that's all it looks like. Now I could write this way, and I should write this way. I'm actually going to write the y on the top and the 7 underneath. Okay, so that is actually 1/7 of y, because if I had 1/7, I'd have that. Okay, but if I've got 1/7 of y, whatever y is, I want to divide that by 7, I've got to put that 7 underneath. So it's actually y over 7. Again, you're not wrong if you do it this way, but that y is actually attached to the top part, really. Yeah, it's probably the better way to think about it. Last one here, 5 is subtracted from k and the result is tripled. Okay, so 5, so D, 5 is subtracted from k, 5 is subtracted from k, and the result is tripled. So whatever we get there, the result of that, so we've got to put that in brackets, is tripled. Okay, is that the way we write it though? No, it's not. So we've got to bring this round to the front, get rid of our multiplication sign, and and then we write it like that. Okay, and that's what it ends up looking like. Remember, we always put the constants and other pronumerals and things that are on their own ahead, and the things that are happening together, they in brackets have to go at the end. All right, and we don't need to write the multiplication signs. So you know, still in here there is a times happening, but we just algebra we don't write them. Okay, so we've got 5. K, take 5, and then all of that is multiplied by 3. It is all tripled. Okay, I think that might be it. All right, just want to quickly have a look at this one. So these two, I want you to do these on paper before we quickly go through them on this. Take 8 from a number and then double your answer. Okay, so I want you to pause. I want you to have a go at writing it up. See what you come up with. Off you go. Okay, welcome back. Again, I bet you some haven't done it and I'm not happy about it. Have a good look in the mirror. Okay, so take 8 from a number, then double your answer. So let's start with y. So our number could be called anything. This one, in this example, they've just called y. We take 8 from that number, which happens to be y. That's what we've called it, because you don't know what it is. And then we double the answer. Okay, remember, that has to go to the front. We get rid of the times. There it is. Very similar to the last example we did. Alright, this one a little bit more tricky. Any 3 consecutive numbers. Alright. This is the way it works. So take a number. We'll call it x. I reckon this one will be called x. Alright. Well, let's look at the numbers first. Let's just say you got 7, 8, 9. So to go from 7 to 8, you've added 1. To go from 8 to 9, you've added 1. Okay. Alright, okay. Alright, so k, we've got to add 1. So k plus 1. And to get to the next one, we've got to add another 1. So actually adding 2. Alright, so this example we've got k plus 1 and then k plus 2, because that is 2 ahead of our original number. Alright, so this will work for any number you were given. So if you're given 7, 7 plus 1 is 8, 7 plus 2 is 9. What if you're given 20? Alright, so just say k is 20. 20 plus 1 gives us 21. 20 plus 2 gives us 22. So 20, 21 and 22. So these will work for any number you put in. You put in any number, it'll give you 3 consecutive numbers. Again, we'll try 100. Put in 100 in for k. 100 plus 1 is 101. 100 plus 2 is 102. So 100, 101, 102. Okay? Hopefully that makes sense. Alright, like I said, it was a fairly lengthy video. Hopefully you understand everything you've gone through. Like I said, there's another short video. I suggest you do watch it. It talks about algebra and why letters are used. But just remember, the letter is not scary. It's just representing a number. We just don't know what that number is. It's a variable. Make sure you have written up these definitions of pronumerals, what terms are, what a constant is, what a coefficient is, and what an expression is. And hopefully you've understood how to, if you're given an expression, how to work out how many terms it's got, what pronumerals are there, and what coefficients are attached to whichever pronumeral. Remembering that if you see a letter or a pronumeral on its own, Okay, the number 1 is sitting there, we just don't write it. Hopefully you understand how to write an expression from that information. Yeah, and how to write algebra, that we don't write the multiplication and division stuff. Okay, we do not need to write it. So 3 times a is just 3a. X times y times z is just xyz. Okay, division, if we did 3 divided by a, it would just look like 3 over a. Okay, hopefully you understood all that. Yep, hopefully you went through and understood all that as well, and you're ready to go for exercise 5a. Any questions, make sure you come and see me. Good luck. Sorry it's been a bit lengthy, but there was quite a bit to get through. Alright, bye bye.